Okay, so let's have a look at example 10. We've got three matrices A, C, and D, and we've got two equations for part A and part B, and we need to solve for the unknown matrix X. So for part A, AX equals C. Right, so our unknown is X. We want to solve for X. Right now, the matrix A is on the left-hand side of X. So to undo the A times X matrix, we need to multiply both sides by A inverse from the left. So A inverse A gives you identity. So IX equals A inverse times C. The identity matrix times anything is the anything itself. So X is equal to A inverse C. So this means we need to do some side calculation, figure out what A inverse is. Then we can multiply that A inverse with the matrix C so we can get our final answer for X. Okay, so A inverse, default formula, 1 over det A. Swap your A and D, negative your B and C, where det A determinant is AD minus BC. Okay, so we're told that A is 3, 5, negative 4, negative 6. Okay, so A inverse is 1 over, or AD, so 3 times negative 6, minus BC, which is 5 times negative 4. I am going to switch my A and D around, so negative 6 first, and then 3 on the other diagonal entry. And then I'm going to negative the B and the C values, so negative 4 becomes a 4, and 5 becomes a negative 5. Okay, let's simplify that fraction over there. So 3 times negative 6 is negative 18, plus 20, so that's negative 6, negative 5, 4, and 3. So half outside of negative 6, negative 5, 4, and 3. So that's A inverse. So to work out X, it's A inverse C. So let's work out what X is. So X is A inverse times C. A inverse is half negative 6, negative 5, 4, 3 times C. Scroll back up. C is column vector, column matrix, same thing. Negative 1 and 2. Negative 1 and 2. A quick mental check, the dimensions agreed, so that's a 2 by 2 and that's a 2 by 1. The insides match up, so that all works out when we're expecting a 2 by 1 answer. So I'm going to leave the coefficient out first. Let's do row by column. So first row by first column. So that gives me positive 6, and 8 is a 14. Next I'm going to do the second row by column. So 5 and 6 gives me 11. And that's my 2 by 1 answer. I'm going to multiply the coefficient inside. So half of 14 is 7, and 11 on 2 is just a fraction, 11 on 2. So therefore X is equal to the matrix 7 and 11 over 2. Now back up here, this blurby bit, you must always write it every time you're solving matrix equations, because that's worth at least 1 good mark in terms of communication. So you're showing off why you're multiplying A inverse then C, not C times A inverse, because order matters. So you're showing development of how you arrive at your answer. So make sure you always write this starter blurb of the A inverses and identities, etc. Okay? Now let's do part B. So here we have XA equals D. Alright, so we're trying to solve for X, the unknown matrix. Our A matrix is on the right hand side. So to undo that times A on the right hand side, we're going to multiply both sides by A inverse from the right hand side. So then you have X times I equals D times A inverse. Matrix X times identity is always itself. So X is equal to D times A inverse. Just a little side talk. So you're thinking, okay, suppose I had XA equals D. Why can't I multiply A inverse from the left? Well, if I go x or A inverse XA equals A inverse D, I really can't do anything about this because I can't just go, oh, let me swap the order of the A and the X around. I can't just magically swap this around to do that, right? Because B times A is not the same as A times B. So the order of multiplying matrices is very, very important. You just can't randomly swap the matrix multiplying around whenever you feel like it. So this is why if your A is on the right hand side, you multiply both sides of A inverse from the right hand side, versus if your A is on the left of X, then you multiply A inverse from the left of both sides of the equation. Okay, let's finish this off. So we need to work out A inverse, but we've done that already in the previous question in part A because A stays the same. So all we need to do is just actually multiply it. So X is, oops, wrong color. So X is matrix D, which is 3, -2 times, what was A inverse again? Half of bracket -6 and -5, 4, and 3. Now, because the half is a coefficient, it's a scalar, it's just a number, I'm going to pull, I can easily rearrange the scalar, the constant number in front. Okay, so I'm going to pull that half out so that I can multiply the matrices first, and then I'll multiply the scalar number inside. So leave the half out. Okay, so dimension check, just to make sure you can multiply this. So that's a 1/2, and that's a 2/2. Inside numbers match up, and I'm expecting a 1/2 answer. Okay, so row by column. So 3 times -6 is -18, and that becomes a +10. So -18 plus 10 is a -8. Next we have a row by column. So 3 times 4 is 12, and that's a -6. So 12 minus 6 is a 6. Now I'm going to multiply the coefficient in. So half of -8 is a -4, and half of 6 is 3. So therefore X is the 1/2 matrix, -4, 3. Now, on an exam, there's an easier way to check your answer, obviously, is to multiply it back out. So if you actually substitute what that -4, 3 times this original A matrix and check, do you get back the D matrix, which is 3, -2. If you do, then great, you've done the correct thing. If not, then you've done something wrong in your algebra, in your math. Another way, if it was a tech active exam, you could check using a graphics calculator as well. But definitely make sure that for all these solving matrix equations, you do explain, you do show this working at the starter blurb of the X, A, D, A inverse identity stuff, so you do get your communication